Before going further, let us recall the error analysis done in previous lecture. We were taking the example of pendulum whose time period is recorded 5 times. First, we find out the mean value and that value is taken as actual value. That is the 3.61 is considered as the actual value. Then find the absolute error, which is the difference between the true value and the measured value. Here the true value is 3.6. The difference between the true value and the measured value is 0.3. 3.6 minus 3.5 is 0.1. Here we are dealing only with the magnitude. We are not considering the sign. That's why the 3.7 minus 3.6 is 0.1 and 3.5 minus 3.6 is also 0.1. After finding the absolute error, we are finding the mean absolute error, which is the average of the absolute error. The mean absolute error is the final error. Now, how the error is reported? The most common way is reporting the error is this one. Best estimate, that is the mean value, and is the mean absolute error. As in the given example, the mean value is 3.6 and mean absolute error is 0.1. So the result is 3.6 plus minus 0.1. Thank you. The next type of the error is a relative error. It is defined as the ratio of the mean absolute error to the mean value. The mean absolute error in this case, in the case of the pendulum, is 0.1 and the mean value is x. So the relative error is equal to 0.1 upon 3.6, which is equal to 0.0277. Now as we are dividing the two quantities, so we retain only 2 digits in the result. As the 0 after the decimal is insignificant, if the number is lesser than 1, so the 2 digit that should be retained is this one. And the number to be dropped is 7, which is greater than 5. So the final result or the final relative error is 0.028. Percentage error is if the relative error multiplied by 100, it is called percentage error. So relative error into 100 is percentage error. As in this case, the relative error is 0.028 multiplied by 100, it gives percentage error. Sometimes there are the error due to the least count of the instrument, which is also called the resolution of the instrument. Thus the length of the pen. Here we are trying to measuring the length of the pen, which is neither on 4.7 nor on 4.8. It is in between 4.7 and 4.8. So its value has this much of error. Now the combination of error, that is how the error is propagated if we multiply, divide, add or subtract the measured quantities. To discuss this, let us first we consider the addition of the two quantities and let delta A is the absolute error in the measurement of A, delta B absolute error in the measurement of B, delta X absolute error in the measurement of X, and we are doing the operation of addition. So the result with error is written in this way, where delta X is the absolute error in the result, delta A is the absolute error in the measuring quantity A, and delta B is the absolute error in the measure quantity B. Rearranging it, this will be the result. The possible values of the delta x are delta A plus delta B. Delta A is positive, delta B is negative. Delta A is negative, delta B is positive, delta A and delta B both are negative. Out of these values, the maximum error is either here or here. So we can say the maximum error is delta A plus delta B. So when we add two quantities, then maximum absolute error in result is the sum of absolute errors in the physical quantity. To make it more clear, let us do a numerical. Two rods are of length 3.161 plus minus 0.3 and 1.121 plus minus 0.1. What is their combined length? It means we are going to add the two quantities and the result is going to write in this way. Now, which is equal to A plus B plus minus delta A plus delta B. Here A is 3.161, B is 1.121 plus minus delta A is 0.3 and delta B is 0.1. So the result is 4.282 plus minus 0.4 centimeter. Here 0.4 is a mean absolute error and this is the mean value. As after the decimal there are the 3 digits, so in result there is also the 3 digits. Here when we are writing the absolute errors, there is only 1 digit after the decimal, so there is only 1 digit. Next operation is the subtraction. When we subtract the two quantities A and minus B, then the result is written as Z plus minus Z equals to A plus minus delta A minus B plus minus delta B. Rearranging, this can be written in this way, where delta Z have these values and the possible values are both delta A, delta B are positive, delta A is positive, minus delta B is negative, delta A negative, delta B positive, delta A negative, delta B negative. The maximum error is either in this case or in this case. So the maximum error in the result is the sum of absolute errors of the